2.6, we're going to look at two different types of solving. The first example is finding a polynomial inequality. Example 2 will be rational inequalities. The first thing you need to do for solving polynomial inequality, step 1, you want it to set one side equals to 0. So you have 2x squared plus x minus 15 is greater than 0. So you always have to start it with one side being a 0. And then the second step you want it to do is finding a boundary point. So when you're solving these quadratic equations or inequalities, you know that you're going to have two solutions, right? 2 points. So we call that boundary points. So we wanted to find the boundary points. So when we're finding boundary points, we need to solve your inequality as the equations to find that 2 points. And when you factor 2x squared plus x minus 15, you will get x plus 3 and x minus 5 over 2. Where you get your x is equals to negative 3 and positive 5 over 2. So this 2 point is going to be a boundary point. So then step 3, let's see if we can mark them on our graph. Also, when we're looking at the inequalities, we need to make sure this inequality we're looking at it have only one variable. So here you have x squared x. You don't see y variable like you are looking at it from your equation or functions. So we're only looking at one unknown, one variable. When you have a one variable, when you're graphing it, this is going to be number line instead of rectangular coordinate systems. So you will have number line. What x can be, they're not dealing with any y values at this point, right? So you have negative 3 somewhere here on the left side. You have positive 5 over 2 on the right side. So this 2 is going to be boundary points. Now we need to figure it out which area will be our solutions. So your option of solution is either this area, left side of negative 3, in between this 2 value, or on the right side of your 5 over 2. And the way that we're going to figure it out, which side is going to be your solution, is by testing the point. So you're going to step 4 is testing that point. If you want to, you can test negative 4. That's the first area that you're going to test. And if you wanted to test the middle area, you can replace x by 0. If you wanted to test on the all the way to right side of the area will be 3, right? So what happened when you replace x with negative 4? You get 2 times negative 4 squared plus negative 4, which you get 28. And we know that 28 is greater than 15. We're comparing what was given from the beginning. So instead of one side equals to 0, we're comparing it here, right? So we replace x here, x there, see whatever the value we get is greater than 15. And we can see 28 is greater than 15. So we will say it checks out that area. So we know that we're going to color this area. This is going to be one of your solutions. You wanted to try the middle area, so we're going to try 0. So when we try 0, we get 0. The 0 greater than 15? No. So we know that the middle area right here is not going to be the solutions. So we don't color, right? We don't color the middle area. Let's see what about the third area, trying 3. 3 is 2 times 3 squared plus 3. You get 18 plus 3, which is 21. And yes, 21 is larger than 15. So we know this area. Any numbers that you try on this area will work out. So we found the area that we wanted to color or include it in the solutions. Then now I wanted to see if we're going to use a bracket or parenthesis. It means are we including -3 and 5/2 or not including? In order to tell that, you need to go back to look at the given problems. We had a greater, not greater than equals to, we had greater. It means it's not including the points that you found. So you're going to use the parentheses. You can use parentheses, or if you want to, you can use the open circle like that, right? Parentheses or open circle will be fine. So that will be the solution of the graph. And always remember, when you're solving inequality, you need to answer your solution with interval notations. Your interval notation is going to be -infinity from -3, where -3 is not included. Use the union sign because you have two solutions. And 5/2, positive infinity, where 5/2 is not included. So this is going to be your solution with interval notations. And this is going to be your solution with graph. Let's look at another one just like that. We have x cubed. X cubed plus x squared is smaller than or equal to 4x plus 4. So remember, very first step of solving inequality, polynomial inequality, was letting one side equals to 0. So we're moving everything on the right side to the left side. Equals to 0 on the right side. Once you set everything to left side and right side equals to 0, now we need to solve as equations so we can find the boundary point. And because this is cubic inequalities, you're going to have 3 boundary points, right? So in order to find that points, you're going to use it as equations. You're going to use equations to solve that 3 points. This is 4 terms, so we can use the group factoring. Group factoring, I will use first 2 versus last 2 if the group factoring works. So let's try if that's working, right? So common factor of first 2 term is x squared. Then you have x plus 1 remains. And common factor of last 2 terms, you wanted to factor -4 out because you wanted to make x plus 1. And from these 2 terms, common factor x plus 1. Now you have x squared minus 4 remains. So remember how to use the group factoring. Then letting each factor equals to 0, you get x equals to -1 from the first factor. And x squared minus 4 equals to 0. you will get x equals 2. Well, let me just not skip any steps. So you're going to get x squared equals to 4. That's 4, if I can write it, right? And then x is going to be plus minus 2. So there is 3 points. Once we have 3 points, remember we're going to draw the number line. Number line because you don't have any y variable here, right? Or function notations. The smallest number will be -2. Then you have -1, and you have 4. So now this problem, you have how many area? You have 1 area, 2, 3, and 4 different area you wanted to test to see if that area is included into the solutions. So from the first area, sorry, my dog is barking. Everyone is at home, so it's hard to find the area that it will be quiet for me to record this. Okay, so let's go back. So I'm going to test out how many different area? 1, 2, 3, 4 different area. So let's test the first area, -3. When I replace x equals to -3, -3 cubed. -3 cubed, you get -27 plus -3 square will be 9. Is that going to be less than equals to, we're replacing it in 2. We're replacing it in 2 where we started. So we're replacing it 4 times x, right? So will be 4 times -3. You're going to get -12 and plus 4. So is it left side smaller than the right side? Yeah, obviously, because you have the bigger negative number, right? So you will say yes, it checks out. What about the next one? Next one, when you replace -1.5 cube, you get negative. You can plug in this to the calculator and you can see this is going to be somewhere close to 3.375. And then you're adding -1.5 square, so it will be 2.25. We wanted to see if this is less than equals to -6 plus 4, right? -1.5 times 4 is -6. And you can tell that's no, right? And if you try this 2 number, I mean, you can if you want to. 0 is easy enough. But if I know without trying, I know this area will work out. Why do I know? Because usually it rotates. If one area works, the next area don't, then the third area should be working. That's why you have boundary points. And they do have some exceptions, and I will show you when that's going to be exceptions. So then I know without trying the number that 0, which is the third area, will work, but I'm going to show you anyway. So 0 cubed plus 0 square, is this going to be less than equals to 4 times 0 plus 4, right? And of course 0 is smaller than +4, so it works out. For the same reason, the fourth one is not going to work. So 1 works. So 1 works. The next one don't work. Then the third one works. So it rotates all the time. So you don't have to try so many different areas if you have many solutions, many boundary points, right? So let's see if we can color the area. The first area worked. Second didn't. Third area worked. And fourth didn't. And now I wanted to see if these points are included, right? So let's see if points are included. When we go back to the given problem, original problem, it had less than equals to, equal sign. So that equal sign saying that you need to include all the points, boundary points. So you're going to either use the bracket or closed circle, right? Dark circle, like that, right? Use the bracket. I like to use the bracket because that way that I know what to use on my interval notations. Or you can do the dark circle like that, either way. So then let me see if I can write my solution next to my graph, right? So I will have negative infinity from negative 2, union of negative 1 to positive 4. So this is going to be my graph and interval notations, inequality solutions. Before we do C, I want you to pause this videos and try this one using example A and B and see if you can get the right solutions. Okay, so first thing we wanted to do is put everything one side, right? I see the parentheses, so maybe at the same time I should be able to distribute 3x. So get rid of parentheses. I get then 3x squared minus 3x from the left side. When I move everything from the right side to left side, I will get plus 2x and minus 10, that's greater than 0. And we need to solve this as equations. So let's see if we can make it standard form, means combine the like term. So it will be negative x minus 10. And let them equals to 0 so we can find 2 boundary points from this quadratic. So then when you factor this, you will get x minus 2 and x plus 5 over 3 equals to 0. It means your x is going to be positive 2 and negative 5 over 3. So this is going to be your boundary points on the graph. So let's see, boundary points, negative should be on the left side. So smaller number on the left side, larger number on the right side. Now we're going to try 3 different areas. 1, 2, 3, right? And because, like I mentioned on the example B, if one area works, then the other 2 don't work, right? Or this area works, then this not work, and the other one works, right? So maybe you can try one of the easy one. Which one should be the easiest numbers to try? So easiest numbers to try in my mind, it will be 0. So let's say I have a 0 somewhere right here. And I wanted to try that 0 or test that area. The middle area is where I'm testing. So then, let's see. I'm going to let x equals to 0. Then I get 3 times 0 times 0 minus 1 should be greater than 10 minus 2 times 0. Which all this, no matter what I have, multiplication, when I'm multiplying by 0, it will be 0. So on the left side, 0. And right side will be 10. So is that 0 greater than 10? No. So because the 0 testing the middle area didn't work, it means this 2 should work. If you don't believe me, you can also test x equals to 3 and x equals to negative 3 if you want to, right? Which x equals to 3 will be somewhere right here, and x equals to negative 3 will be somewhere right there. When you try these 2 points, you will find out that both of them not work. Both of them work, right? So that's going to be your graph solutions. And your interval notation will be negative infinity from negative 5 over 3 unions 2 to positive infinity. And I use the parenthesis because when you go back and look at the given problem, you have a greater, not greater than equals to. So because you had greater, you're going to use the parenthesis. That's why your solution had parenthesis too. So if you wanted to box or circle your final solutions, this is going to be your graph and interval notations. Okay, if we're looking at one more example for solving polynomial inequalities, this is the one that it's going to give you when it's going to be exceptions of rotating area of the solutions. So I'm going to show you that. First, again, same thing. Set one side equals to 0 and make it all descending order. So negative x cubed become plus x cubed. And then negative 8x squared. And then you have negative 12x is greater than equals to 0. So set it as standard form and one side equals to 0. Once you have that, then you need to solve this, right? So when you're solving this, I don't know if group factoring works. So what I like to do is using synthetic division method on this one. We just did the synthetic divisions in 2 sections before. So let's remember that synthetic division. So coefficient is 1 from the 4th power, 1 from the cube, negative 8 from the square, negative 12 from the linear, and you have 0 from constant. And we wanted to divide this by, let's see, your factor of last term is 12. And leading coefficient is 1. So factor of 12. One of the factor of 12 should work. And because you have first two positive, 2 negative together. So probably I will try the negative number. Because I need to go all the way to large number 12, maybe I will start trying negative 2 to divide first. Maybe this don't work out, then I will try higher numbers, maybe negative 4. I think negative 4 is too big. Okay, so then this gives you negative 2, which is going to be negative 1. This is going to be positive 2, which is going to be negative 6, and that's positive 12, that's 0, right? So once we factor from this, using synthetic divisions, look like you can factor x plus 2, then you will get what's left over, which is x cubed minus x squared minus 6x. And from the cube, I can tell that I have a common factor. So this, I have a common factor x. So let me factor x out. So then I'm going to factor out x all the way in front. Then I will get x squared minus x and minus 6. And I know I can factor that quadratic, which will give me x minus 3 and x plus 2. So you could say you have x equal 0, negative 2, and positive 2 as the solutions. Here you need to make sure look like you have 2 of negative 2 as the solutions. This is when your solution is going to be not skipping one area. This having 2 same solutions, the area after is going to be different. So let me see if I can graph this. And mark the boundary points. We have 0, -2, 3. So -2 will be the smallest. And then we have a 0. And we have +3. We should be able to test 1, 2, 3, 4 different areas. So let's see if we can test 4 numbers. We can test maybe -3. We can test maybe -1, +1, and +5. So if we try -3, then you will get -3 to the 4th powers is 81. Well, if I can write 81, it will be 81. And minus 12 times -3 is +36. Let's see if this is greater than or equals to. -3 squared is 9 times 8 will be 72. Plus, because you're cubing 3, -3 times -1, right? Oh my God. Trying to write plus sign there. For some reason I cannot write positive sign right there. It looked like divisions. Let's see if I can do this. Okay. And then what else I'm doing? -3. Yeah, -3 cube. So minus, so it will be +27. And see if this is true. 81 plus 36 is obviously larger than 72 plus 27. So yes, right? What about when x is -1? -1, you're going to get +1 plus 12. That's greater than +8 plus 1. Don't forget, right now you're plugging all these numbers here, where you started, right? To see if this inequality holds the true statements. So, let's see. Is this true? 13 is greater than 9. Yes, that's true. So remember on the other problem where one works, the other one didn't work. But because we have -2 between, one worked, this one worked, instead of not working, is working again because you have 2 of -2 as the solutions. Remember having a 2 of the solutions, right? So when you have a 2 of the solutions, usually when it was one works and the other don't work. Now, because 2 of the solutions, it will still working. One worked and this one works too. Okay, that's the exceptions that I was talking about. Then the next one should not work because we only have one solution of 0, right? So let's try that. When we plug in x equals to 0, why am I trying 0? We need to try 1, right? We're trying 1. So then when we try 1, I get 1 minus 12 and 8 minus 1 on the other side. So this is not true. Negative 11 is not greater than 9, right? No. And if we try 4, the last area, it should work this time because it's rotating. So it will be 4 to 4th exponent is 256. 4 times negative 12 is negative 48. And then you get 8 times 16 is 128. And 4 cubed is going to be 64. And when you simplify that, this is going to be true, right? The left side right here will be bigger than right side. So you know this is true, yes. So when you're coloring, this work, and also the next area work because you had 2 of negative 2. But after the boundary point 1, it's not working, and after the boundary point 3 is working. And when you look at the given inequality, you have greater than equals to. Whenever you have equal sign, use the bracket. So it will be bracket on those 2 points. And if you wanted to write interval notation of your solution, will be 0 to infinity and 3 to infinity. Well, 0 to negative infinity, unions of 3 to positive infinity. So this is going to be solutions and this is going to be graph. Example 2, we're going to talk about how to solve rational inequalities. Rational inequalities start the same as polynomial inequalities. So it means you're going to start by letting one side equals to 0. So if we do that, we get x plus 1 over x plus 3 and minus 2 is greater than equals to 0. One side equals to 0, this is how you get. Once you simplify one side equals to 0, well, once you made one side equals to 0, then you wanted to simplify the other side. So your left side, you have 2 terms right now. You wanted to make it this into 1 fractions. So in order to make it 1 fractions, you know that you have to have same denominator. So 2 become 2 times x plus 3 over x plus 3. So you're multiplying numerator, denominator by x plus 3. So then you end up getting on the numerator x plus 1 minus 2x minus 6 all over x plus 3. And then when you simplify your numerator, you get negative x minus 5 over x plus 3. And we know this is what? This is still greater than equals to 0, right? You just did simplifying on the left side. So once you simplify left side into 1 fractions, then you have 2 boundary points, one from the numerator, one from denominator. So the numerator, negative x minus 5, will give you 1 boundary point. And that's going to be negative 5. And denominator will give you another boundary point. So then we can draw the line, mark the boundary points, and test the area. And maybe you can test what? You can test negative 6, and you can test -4, and you can test positive 0. Oh, well, negative, positive, same thing, 0, right? 0 is always easy numbers to play. So then let's try with the easier one, which x equals to 0, right? When x equals to 0, you get 0 plus 1 over 0 plus 3. That's greater than equals to 2. Let's see if this is true. We get 1/3 is greater than equals to. Is this true? No. 1/3 is smaller than, so it will be not. No. So when we try 0, when we try this area right here, didn't work out. So I know this should be work and this one should not work. So just trying one area, and we only have one of each solutions, so I know only middle area work. If you don't believe me, you can try -4, and you can try x equals to -6, and you will know that this work. -4 works, and -6 not work. And when we go back to the beginning of the problems, remember here we had greater than equals to. So we're going to use the bracket. We're going to use the bracket, exception of, remember this part right here, your inequality, you cannot have x equals to -3. So this is your restrictions. You cannot have x equals to -3. So exception of that, you can include your boundary points. So in other words, you can use this one as a bracket. But this one you cannot use the bracket. You need to use a parenthesis. Why? Because your restrictions. So then your interval notation will be bracket, parenthesis, -5, -3 in between. Let's try another one. So B, we have 4x plus 5 over x plus 2 is greater than equals to 3. So first thing we need to do always inequality. We wanted to make one side equals to 0. So subtract 3. Then you wanted to simplify left side, make it one fractions. So then you have 4x minus 5 over x plus 2. And you wanted to make denominator x plus 2. So you need to multiply 3 by x plus 2. Then you get 4x minus 5 minus 3x minus 6 on the numerator, and denominator is x plus 2. When you combine the like term on the numerator, you get 4 minus 3 and -5 minus 6. And don't forget, this is still greater than equals to 3. So here you get from the numerator 11, from denominator -2 as the boundary point. Before we go any further, I found a mistake here. So remember when you're looking at the given problem, it was additions. Somehow I forgot to write addition, I wrote subtractions. So if we change that, additions. This should not be 11. It should be -1. So let's erase that. -1. And it means x is 1. So that's good that before we mark our boundary point, we saw the mistake. So we have -2 here and +1 as the boundary point. So again, 0 is easy numbers to test it. And I see somewhere here you're 0. So when I plug in 0 into the original problem, when x equals to 0, I get 4 times 0 plus 5 over 0 plus 2 should be greater than equals to 3. Let's see if this is true. So you get 5 over 2 is greater than equals to 3. Well, that's not, right? That's not true. 5 over 2 is 2.5, which is not greater than 3. So it means the area that contains 0 is not going to be a solution. So it means one on the left side and one on the right side should be the solutions. And if you don't believe me, you can also try different points from those two areas. And your original problem say greater than equals 2, so you can use the bracket. But another exceptions that you have is here. Your restriction is you cannot have x equal -2, right? So we cannot include it. You can use the bracket on any other points exception of your restrictions. So if you write your interval notations, will be -2 not include union and bracket of 1 to positive infinities. So graph and interval notation of your solutions for the second problem. This is the last problem of 2.6. Rational inequalities. So if you want to, pause this and try for yourself and see if you get the right solutions. Always start by making one side equals to 0. So we'll have 1 over x minus 2 minus 1 over x plus 3 is greater than equals to 0. Once you make one side equals to 0, then you wanted to simplified left side, which means you wanted to make it one fractions. So let's do the subtractions. In order to do the subtractions, you need to have same denominator. Your least common denominator of given two fraction is x minus 2 and x plus 3. This gives you your numerator 1 times x plus 3 and -1 time x minus 2. So you get -x and positive 2, right? Don't forget you're multiplying this by x minus 2 and this numerator by x plus 3. And when you simplify numerator you end up getting no more variable x, only 5, denominator x minus 2, x plus 3. So here, numerator do not give me any boundary points because I don't have variable x. But denominator, I end up getting 2 boundary points. positive 2, negative 3. And also at the same time, this is my restriction also, right? I cannot make these points included. So even though you have greater than equals to sign, you're not using a bracket, you have to use parenthesis on these 2 boundary points. So let's mark those 2 points. Negative 3 smaller than positive 2, so on the left side. And when we try, if you're asking me to pick testing points, my testing point will be always 0. So let's say your testing point 0 means you're testing the middle area, right? So when you let x equals to 0, then you get 1 over 0 minus 2 is greater than equals to 1 over 0 plus 3. You get negative 1 over 2 and positive 1/3. Obviously, negative number is smaller than positive number, so middle area is not included, right? It means your solution include both n, right? This area, that area. And even though it is equal sign, you do not use bracket because this 2 point is also restrictions. So we need to use the parentheses. And if you want to write in table notation for that solutions, you get negative infinity from negative 3 and to positive infinities. Graph and interval notations of solutions.